So continuing with our lesson from yesterday, I want to take a look at two more methods that you can use for solving trigonometric equations. So the first example today, which is really example 5 in the whole lesson, is an equation that looks like a quadratic. So if you look at our equation here, we have 2 sine squared x minus sine x minus 1 equals 0. Now this looks a lot like a quadratic because we can see that in our first term, the sine is being squared. In our middle term, we have just the sine, not squared, and our third term is just a constant, all being set equal to 0. So, because it looks like a quadratic, we want to use quadratic means for solving it. So that means we want to factor it like a quadratic and then solve it like a trig function. But that can get a little bit complicated and maybe a little confusing if you're trying to do that all at once. So this would be another good place to think about u substitution. So every place I have sine of x, I now want to insert a u so that I can just concentrate on the quadratic nature of the equation, factor using the quadratic means that I know, and then we'll substitute sine of x back in to deal with the trigonometry aspect of the equation. So if I rewrite this using our u substitution, I'm going to have 2 u squared minus u minus 1 equals 0. Okay, so you can see I'm just substituting a u in for sine, and now we're going to solve it like a normal quadratic. So, what are the factors of 2u squared minus u minus 1? Hopefully you remember our techniques from the quadratics chapter back at the beginning of the year. We should get 2u plus 1 and u minus 1. Okay, and just like we did when we talked about quadratics, we're going to set each factor equal to 0 separately using our zero product property. So that means 2u equals negative 1, and u is going to equal negative 1/2. And here we're going to get u equal to 1. And just for the sake of simplicity, let's go ahead and limit this from 0 to 2 pi when we're trying to find our answers. Okay? So I've solved for u now, but this did not originally ask me to solve for u. This asked me to solve for x. So now I need to put my sine of x back in for u. So sine of x is going to equal negative 1/2, and sine of x is going to equal 1. Okay, move that back up here a little bit so we can see. Okay, so now I can solve for my x's. So again, thinking about sine, I need to figure out my reference angle and the quadrants that we're in. So with 1/2, if I ignore the negative for just a second, a sine of 1/2, if I go to my fingers, I need 1 finger for sine, so that's going to be over here, which means I need to put this finger down. Okay, and so that means I have a reference angle of pi over 6. Now we want to take a look at the fact that this is negative and decide which quadrants we must be in. So again, for sine, we have to be in quadrant 3 or quadrant 4 to be negative. So which angles in quadrant 3 and 4 have reference angles of pi over 4, or excuse me, pi over 6. We would be talking about 7 pi over 6 and 11 pi over 6. Okay, then I come over here to the sine of x equal to 1. Well, if sine of x equals positive 1, since sine is the y value, we would be talking about right here, and so that's going to be at an angle of pi over 2. Okay? And so our final answer is going to be that the x value could be 7 pi over 6, 11 pi over 6, or pi over 2. Okay? But we're using a quadratic method to solve this, and in those cases, U substitution can be very helpful so that you can just concentrate on the quadratic nature of the equation first to get it factored, and then concentrate on the trigonometric aspect of the equation to finally solve for our variable. All right, last example for this lesson, and then you'll have some time to work. So for example 6, we have an equation of 2 sine squared x plus 3 cosine x minus 3 equal to 0. Now this one's a little bit tricky because we do have a trig function being squared and a trig function not being squared and a constant. But we cannot just use the quadratic to factor this because our trig functions are different. So we need to be able to rewrite this using a single trig function so that we can then use the quadratic factoring to get our answer. So which trig function can we replace with an identity that contains the other trig function? In other words, is it going to be easier to find something to replace sine squared with something that has a cosine in it? Or is it going to be easier to replace cosine x with something that has a sine in it? So again, looking at your identities that you can use, I believe the best choice is to replace our sine of x, sine squared of x, excuse me, using the Pythagorean identity and replace it with 1 minus cosine squared x. Okay? Now, what that means is before I can work this as a quadratic, I need to distribute the 2 through these parentheses and simplify this left side. So, distributing gives me 2 minus 2 cosine squared x plus the 3 cosine x minus the 3 equals 0. Now, I prefer to keep my leading coefficients positive, and so I'm going to actually pretend like I'm moving everything over to the other side so that my square term will be positive. You can also think of this as multiplying everything on this side by a -1 and then combining like terms. So either way, we end up with a positive 2 cosine squared x, a -3 cosine x, and then a positive 1 for our constant. And again, all of that's equal to 0. Now we're back to that quadratic looking equation like we saw in the last example. So this would be a good time to bring out our U substitution and substitute U in place of our cosine. So that means we're going to have 2u squared minus 3u plus 1 equal to 0. When we factor this quadratic now of 2u squared minus 3u plus 1, we're going to get a 2u minus 1 and a u minus 1 equal to 0. So now using our zero product property, we have the 2u minus 1 equal to 0. We can set u minus 1 equal to 0. We get u equal to 1/2, and we get u equal to 1. All right, we're getting close. So we've solved for u, but it's not u we're interested in, it's x. So now we have to substitute cosine back in for u. So now I have cosine x in place of u, and cosine x is going to have to equal 1/2 or 1. So this time we need our cosine to give us a 1. So the cosine being 1 means that this finger needs to go down because cosine is on the left side. All right? So in order to get a 1/2, we need to put down the pi over 3 finger. So we have a reference angle of pi over 3. And which quadrants are we going to be in? Well, since we're talking about a positive answer for cosine, cosine is positive in the first and the fourth quadrants. So quadrant 1 and quadrant 4. So what angle measures in quadrant 1 and quadrant 4 have a reference angle of pi over 3? That would be pi over 3 and 5 pi over 3. Okay, then we come over here to our cosine of x being equal to 1. We know 1 actually puts us on an axis. So again, we just have to think about when is cosine equal to 1. That's when we're on the x-axis out in this direction. And so that's when x equals 0. And so our final answers here, our solutions, are, this will be true when x equals pi over 3, 5 pi over 3, or 0. Okay? All right, so that gives you a lot of different methods that you can use. Most of the problems that you see in the practice will probably use one of these methods. You might see some that uses something slightly different, but you should be able to figure out your approach based on the 6 examples that you've seen now. And you should be able to get through your practice using the same technique. You should have quite a bit of class period left that you can be working on this, so working together and talking to your friends about this would be a good idea. Certainly make sure that you're checking your answers. And when you do the problems on the worksheet in your booklet, I don't remember if it says for sure or not, but I do want you to do all of your problems by finding solutions on the interval from 0 to 2 pi. Okay, it might already say that in your booklet, I don't remember for sure, but even if it does not say this, this is what I want you to do. And I'll double check the answers if that's the way I gave you the answers. But all of your answers are from 0 to 2 pi, okay, one rotation around the circle, using one of the 6 methods you've seen or some variation of them. All right, if you have any questions, make sure you find someone who can help you out or send me an email and I'll try to get back to you as soon as I can. And this is the last lesson for this chapter, so we'll be getting ready for our test here in the next couple of days. We'll have a quiz and then a test, and then we'll move on to our last couple of chapters for the year, which will deal with probability and statistics. So, good luck on your test, and we'll see you with the next lesson.